Guys, welcome back to Maison African Motives, still on our industrial electronics and for working on the transistors and amplifier conditions. We just want to see, we've got typical questions that we'll see in our exam, whereby you'll be given conditions where you are dealing with the gain, you are working with the gain. We talked about this from our industrial electronics N2, right? So we had conditions where we are working with the gain, whether it's from the power, from the voltage, from the current, and so forth. So it's still one and the same thing. And also the calculations are not going to change. If you remember in N2, we've been talking about most question on a loudspeaker, whereby we're talking about the condition of a loudspeaker. We've got the input impedance, and we've also have the output impedance that is going to affect. So your impedance, which you can write as ZO for output and ZI for the input, or you can even write in, will determine the power that you are given and also the voltage, depending with, is it the voltage in or is the voltage out? So what is important is that if we are working with the power, which formula are we going to use? And also how are we going to apply the formula? All right, so let us just quickly have this. We do not waste much time. We had this from our N2. So given the following information is given for an amplifier in this case, whereby the input power, so we've got the input power, the voltage in, and so forth. So this is the information that you're given, the power in, that is 500 milliwatts in this case. We've got a small letter for the milliwatts. Then the input voltage, which is Vin, or you can write as Vi, depending on the way that you understand, which is at 15 volts. And we've got the output power, the power that is corresponding at the output, which is 450 watts. And also the output impedance, not the voltage, but we are given the output impedance, which is 15 ohms in this case. Then we're asked to calculate the power gain in decibel. Whenever we are dealing with the decibel concept, for power, it is going to be 10 log. We are going to use 10 for the logarithm. Remember, like I said, guys, we had these formulas from our N2. So remember that the power gain, which you can just write in short AP, A is for gain, then P for power, is given as the 10 logarithm of P out, that is the output of the input. All right, so this is supposed to be base of 10. But as we know that the moment if you're dealing with logarithms, the logarithm of 2 in base of 10 is the same as just the logarithm of 2. So we're given the base, which is a 10, which is not important to indicate on your simplification. So this answer is going to be in decibels. Are we having everything? That is the question. Are we having the power out, the power in? We have it. So just going to substitute. So that is our power gain is going to be 10, the logarithm of P out, which is here, but P out from our information, that is 450 over P in, which is 500 times 10 to the exponent of -3. So your answer will be in decibels in this case. So it's just a matter of you and your calculator. In this case, we are just supposed to be careful on your simplification. There's no need for you to indicate the base, so just use the normal log as it is. What am I trying to say? The normal log here on your calculator, which is 10, the logarithm, this one, it's already in base of 10. Then we need a fraction. So we are going to have 450 over 500 times 10 to the exponent of -3. So this is how we're going to use for each and every simplification. So I'm just going to illustrate for this one only. All right, so that is going to be 29,542,425 and so on and so on. All right, so that's the answer that you're going to have in decibels in this case. All right, so meaning to say here, we are going to have our power gain. We got 29, 5424 and so on. So it's going to be 542 in decibels. All right. So that is how we can end up with the power gain. And every other gain that you are going to have, it's voltage, it's current. We are going to have the same concept, but here you are going to have 20 log, it's V out over V in, 20 log I out over I in. That is what you're going to do for all the rest. We are going to work with the 20. 10 is for power. All right, I think we are recapping from our N2. Like I said, anyways, let us check the second question. Here was to calculate the voltage gain in decibel. All right, so like I said, for voltage current, we are going to use 20 log. All right, so the voltage gain is going to be given as 20, the logarithm of V out over V in. All right, so the question is, are we having these V out and V in? From the information, this is what we have here. From our information, we've got V in, we do not have V out. So as we can check, we have got V in, which is fine. V out, we do not have. We are supposed to have V out here so that we can be able to use it on this part, and we do not have that V out. So what are we going to do? Remember, this is mathematics, guys. Change of subject, this and that. Calculations. This is all about calculations. Whether you're talking about industrial electronics, you're talking about engineering science, it's all about maths. So the question is, you have to ask yourself, where am I going to obtain this V out from the information that I'm given here? Where am I going to have my V out? Okay, since we've got the power output, let's think from there. Because we are talking about V out, so there's no way we're going to talk about V in unless maybe there's a formula that connects V in and V out. But here we're supposed to think about these two that we are given. How are they connected, the power and the impedance? The impedance is just like the resistance, the normal way that we talk about resistance. All right, so let me just try to have it and explain it here, because this part, a lot of us have got a lot of confusion here to say the power. Let me give you back to the normal DC circuit. The power is equivalent to the voltage times the current that we know. And also the power is equivalent to the voltage squared over the resistance. The same power that we are talking about is equivalent to the current squared times the resistance. So this is what we know, and we are going to use the same concept. Though we are talking about impedance, this is the same as a normal DC circuit when you are dealing with what? The decibel concept. So meaning to say, we'll be talking about the impedance in place of the resistance, and here we're talking about the output. So meaning to say our P out can be written as V out times I out. Let me just use all that in short, all right? That is V out times I out, current out. All right, the same power that we are talking about can be given as a V out squared over the impedance. All right, the impedance for the resistance. So you're gonna have the impedance at the output. The same power that we are talking about can be given as the current squared at the output times the impedance now at the output, which is representing the resistance. So the question is, what are we given? That is what I'm saying. We have got three formulas that we are going to apply, or three formulas that you can use to calculate power. So when I am given power and the impedance, which is the best formula that I can use in order to calculate V out, because I'm supposed to use this to find out or to determine V out. So I need the part that is, there is power, there is impedance, there is voltage. Power, impedance, and voltage. Which part are we going to talk about? We are going to talk about this one. Power, impedance, and voltage. This is the best formula that we are supposed to think of. It has the power, it has the impedance, it has the voltage. So from that formula, we are supposed to find V out. So we can make V out the subject of the formula. It's up to you guys. This is actually in your hands. Let me just put it this way. So like I said, these formulas are simply taken from our normal DC calculation, all right? So here we are going to use this formula to calculate calculating V out. That is, we're going to calculate V out. All right. So in order for us to have V out, in this case, we're going to have this formula, which states that P out, which is the power, is equal to V out squared over the impedance. That is what we have. Yes, you can use whatever formula. Maybe you want to calculate the current first, then after that, you use this one to calculate. Guys, it's up to you. but this is the best formula. It has what we need and what we are given at the same time. So in order for us to find V out, let us just cross multiply here so that we make V the subject. That's going to be P out, Z out is equal to VO. So we're going to introduce the square root. Remember, I've got a square there. So we're going to introduce the square root both sides so that we remain with the V out, which is going to be the square root of P out times Z out. So meaning to say, in order for us to calculate the voltage at the output, which is the voltage that we need here, we are going to have the square root of P out times Z out, which is the P out. Remember, I've got P out 450 and the impedance there, which is 15. So it's 450 times 15. So we're going to multiply 450 times 15. That's it. We've got the voltage at the output, which is going to give you something like 82,158 volts. This is voltage measured in volts in this case. So since I have got this voltage, I'm just going to simply substitute because I'm having all the rest from this information. V in, I'm having V in here, which is 15. So we can calculate our gain at this end, which is the voltage gain. So it will end up to say that we can end up saying the voltage gain is equivalent to 20, the logarithm of V out, whereby we calculated our output voltage here, which is 82, so we got 82,158 over the input voltage, which is V in. All right, so that's what you're going to have, and our answer is going to be in decibels. All right, so that's our V in, which is 15. So we're just going to substitute 15, which is VA in this case. All right, so that's it. Like I showed you guys on the calculator, you're going to use your calculator direct. You simplify this, you're going to obtain 14,77117, which is 14,771. All right, that's in decibels. So that's we're going to have the voltage gain in this case at the end. So as you can see, you'll be having the formula, but limited to a certain information where you have to manipulate your formulas to the favor of what you're supposed to be calculating. That's where the maths part plays a role. You have to be good in maths. In actual, I always say, if you're doing engineering, to be honest, guys, if you're doing engineering, the easiest subject must be mathematics. That one is supposed we can't argue on that one. If you're doing engineering, easiest subject must be mathematics. So please revise your mathematics as much as you can. That you will see what I'm saying. You will see. All right. Anyways, let us see the current gain in decibels. We need the current. So like I said, the current, the voltage is going to be using 20 log. So you're going to apply 20 log in this case. Let me just use this space here because I don't think we're going to need this voltage gain. So let us just remove it. All right, so that's 4.23 in this case, 4.23. We need the current gain, so just going to use current gain is equal to 20 logarithm of the current output and over the input. All right, so the whole part is output over input, but current and voltage, you're going to have 20 log. Are we having these values current? In fact, we are not given any current here. All right, let me just utilize this space here. Why can't I just remove this? Because we are done with this part. All right, so as you can see, we do not have any. This one we do not have, this one we do not have. But we have got advantage. Let's check at the input, what we have at the input so that we can have the current in. All right, so at the input, this is what we have. We are given V in and P in. So let's think along having V in and P in and V in. How are we going to calculate current in? So remember from our formulas, I talked about this. It's not going to change because it's power. We need where there is voltage, power, voltage, and current. So we're going to use this formula. Power is voltage times current. So it's going to be P in is equal to V in times I in, because we have voltage, we need current, and we are given power. So that is the best formula to use in order according to what, guys, these formulas we use according to what we have. And we can see that we've got power, voltage, we need current. So you can use power is equal to voltage times current, but this will be P in, V in, and this will be I in. So we can calculate the input current if we divide by Vn both sides. So that will cancel. So you're gonna have the input current as P in over V in. All right, so let us just substitute here. The power at the input is given as 500 milliwatts, which is 500 times 10 to the exponent of -3. The voltage at the input is 15 volts in this case. So if we divide this, we are going to have the input current, that is the current at the input, which is a current in is going to be 0,033 to 3 decimal place. I just rounded off to 3 decimal place. All right. What about the current at the output? Current at the output. What are we having? Because we now have the input at the output. Like I said, we just have to work with the information. This is the information that we have at the output. And also, remember, we calculated V out from that concept. We also have V out. So you can choose to work with the V out, or you can just choose to work with the original values. If you want to use V out, therefore you choose the formula with the V out, you can use this one. P out is equal to V out times I out. Or you can choose to say, maybe this value is wrong because you are in exam. I'm not saying mine is wrong. I'm saying maybe your value is wrong because you're under exam, you've got this exam pressure and this and that. You calculate you've got a wrong answer, meaning to say whatever that you're going to do, you're taking it from a wrong answer. So it is wise enough to go back to the original values and use original values. All right, so that if that one is wrong, therefore this one cannot be wrong because you're taking it from what? Original values in this case. So the question is, we are supposed to calculate the current at the output in this case, given power and impedance. What is the best formula to use given power, impedance in order to calculate current? This is the best formula where we are given power, current, and impedance. So we're going to use that formula to calculate the current because we've got the power at the output. We also have the impedance at the output in this case. All right. So like I said, we are going to use this formula. So let us just write it down. I just hope you noticed our formula. So we can just even fit it in here. All right. Let me just try to fit it here. So we are simply saying from this information that we got, remember, we said we're going to use this formula, power, current, impedance. All right. So you need power, current, impedance. So that is for the output. All right. So you notice that the power is going to be given as I squared times the impedance. So this is at the output. So you're going to just have it at the output. All right. So you can just write out. It's fine. All right. So we want to calculate the current. Let us make it the current the subject. Remember, this is what we want. We've got power, impedance, and we want to calculate the current. So we can divide by the impedance for sides. Let's divide by impedance. That is, the current squared will be the power out over the impedance. So you can introduce the square root both sides to remove the square there so that we remain with the actual value of current, which is the square root of P out over Z out. All right, so that's it. We have these values, so we can calculate the current at the output in this case by simply substituting the power. At the output is 450. So we are going to have the square root of 450. So that is our current is going to be the square root of P out 450 over Z out, which is the impedance at the output, which is 15. So there we are going to obtain a 15. That's it. We can calculate the output current from there. And this gives us the exact value. It's not from any rounded figure. We took from original values. So here we are going to obtain the exact value, which is going to be 5,477 amps. Remember, this is current, and we know that current is measured in amps. So we have got the output current, we have got the input current in this case. So we can use this to calculate our gain. Remember, I said here that gain, the current gain is going to be given as 20 log current at the output, which is we have got the current at the output of 5,477 over the current at the input, which is IN. So this is our current at the input, 0,033. So we're going to have 0,033. And this gives us our answer in decibels in this case. All right, so that's our current gain is going to be given as 44,40057, something like that, which is going to be 44,400. 401. All right, to 3 decimal places, you're gonna have our answer to 3 decimal places, and that will be our current gain in this case. So as you can see, it's just direct and straightforward. Not that straightforward. We just have to know your formulas. So these are the 3 formulas that you're supposed to know and play around them. All right. It's best that you know all of these 3, because sometimes we might use the first formula, we might use the second one, we might use the third one. So it's best that you know your formula so that you won't struggle to make or to find whatever that is missing from the information that you're given. So that was actually 10 marks for that, right? Which is fine. Yeah, which is fine. Let us check the other question and see, because this can be given in different ways. This time we are given the following data was for an amplifier, the input voltage, the output impedance, output power, input power. Are we not having the same information as the last time? Okay, let us just see. If we are having the same information, it's fine to be for a revision. So we've got the input, in this case, we've got the input voltage, that's Vn, right? This is too much. All right, why this page is bigger, the other one, it was smaller. Anyways, let's see. Okay, let me just try and have it here. So that's Vn from our information. Our Vn is going to be given as 30 volts. Output impedance given as 80 ohms. All right, then we also have the output power. The output power given as 200 watts. And the input power, this seems like very, very similar to the last question. Anyways, let's see. So the question was calculate the voltage gain. All right, this time they do not have the power gain. They just straightforward the voltage gain. All right, so that's it. Let's see. What are we supposed to do? Because we need the voltage gain there. So from our calculations, we said the voltage gain, remember, it's going to be using a 20 log, right? So that's the voltage gain is going to be 20 log of V out over Vn. All right, so that's it. Are we having V out? We do not have V out. We do not have V in this time. We just have V in. So V out, we have to think of the output power and what impedance and power here. So these are the 2 formulas that we are supposed to be thinking to work on. I mean, this not 2 formula, but these 2 values. So which formula? Remember, I said we can have our power in different ways. We can have our power being current times the voltage times current, or power being voltage squared over the impedance, or power being I squared times the impedance. So which one is going to be the best formula to apply when given power, impedance, and we need voltage at the output? So I think we're gonna go back to this formula, and we used this formula before. Let us just use that one. So we notice that power is equivalent to V squared over the impedance. So that's at the output, at the output, at the output. We're just gonna use output, output, output throughout. So that's it. We can calculate the V out in this case, which is this one that we do not have here. So here we are simply calculating V out. So we're gonna work out V out. So let us just cross multiply here, cross multiply. That will be V out, the subject is gonna be P out, Z out is equal to V out squared. The square root both sides, so V out is the square root of P out times Z out. All right, this is a repetition, and just repetition from the last question. As we can see, that's it, which is fine. It's good for revision. So it's gonna be P out, which is the output power, that's 200 watts. So it will be 200 times Z out, which is at the output, the impedance is 80. So that's our V out there was going to be 126,491. All right, so having this, we can determine the voltage gain, because already, like I said, the input is there. So we're just going to substitute. That is, our voltage gain is going to be given as 20 logarithm of V out. The voltage at the output, that's 126,491 over the V in, which is the voltage at the input we are given here, which is 30 volts. All right, so that's it. We're gonna have our voltage gain in decibels in this case. All right, so if we are to simplify this properly, we were going to obtain 12,49. That's 12,4987, something like that. So it's gonna be 499 in decibel. All right, so that's how we could have calculated our voltage gain. All right, then the current gain again in decibels, 3 marks, the current gain. So as you can see, for current gain, we're gonna need current, and we do not have any of the currents here. So we are back again to the calculation, just like the previous part. So as you can see, this one was just more of a repetition of what we did previously. So like I said, it's best for you to use original values. Yes, you can use that V out that you calculated, which is fine, but it's best for you to use original values, all right? So 5.22, you're gonna have our current gain as 20 logarithm of the output current over the input current. All right, so that's it. And we do not have any of these two. So in order for us to have the input current, you consider what we have at the input. At the input, you have got voltage and power. So to find current, this is the best formula on top, where we are saying P is equal to VI. So we're going to use the formula on top to calculate current. Calculating current at the input. So we saw that the power is equivalent to the voltage times the current. So that's Pin is equal to Vn times In. So like I said, just going to divide by Vn both sides so that we remain with the current. So the current at the input is simply going to be Pin over Vn. That's Pn 15 and Vn, which is 30. So it's going to be 15 over 30 in this case, all right? And remember, this is current measured in amps. That will be 0.5 or a half, all right? A half is same as 0.5, so that's 0.5 amps. We do the same thing to calculate the output power in this case, since the output current, since we are talking about the gain of current. So we are going to calculate the output current, all right? So calculating output current. What are we given? Because we need the output current, yes, but what are we given at the output? At the output, we have given impedance and power. So how are we going to calculate current given impedance and power? Impedance and power here, this is the best formula, where power is equal to I squared times impedance. So you can see that power is I squared times impedance. So at the output, this will be output, output. And we want to calculate the current there. So just divide by Z naught both sides. So that will be I squared. All right. The output current squared is equal to power over impedance. So to find this, just gonna introduce the square root to remove this square. Just introduce the square root. So that means the output current is simply the square root of P out over Z out. And we have the power at the output. Remember, the power at the output is 200. So that is going to be 200 over the impedance at the output. At the output impedance, it's 80. So that will be 200 over 80. Everything is under the square root. The square root is going to affect each and every part here. So it's square root of 200 over 80, which is going to be 1,581 in amps. So that's it. We have got everything that we need: output current and also the input current. So these are the values that we are simply going to apply or to use in order to obtain our gain. And we said the current gain is given as, so this is I for current, that's the 20 logarithm of the output current, which is our output current 1,581. So you're gonna have 1,581 over the input current, and here our input current is 0.5. So that's a 0.5 in this case. All right, so this whole part is going to give us the gain of current in decibels in this case. All right, so the gain of current, or the current gain, was going to be 9,99923, something like that, which is 9,999 decibels in this case. Yes, you can approximate this to 10 decibels, which is fine, but the answer was supposed to be 9,99 like that in decibels. So which is just approximating to what? To 10, which is one and the same thing. So that's it. As you can see, it can be like that. So this is how our questions might be given. And lastly, we've got an amplifier has got the following data. So this is the data or the information of an amplifier given the input, output, and output impedance. Calculate the current gain in this. I think this one is just also a repetition. This time they just need us to calculate the current gain. All right, so let us just save our information here. Remember from our calculation, we say the current gain is equal to the 20 logarithm of the output current over the input current. All right. So if we are to substitute our information here, we are going to see that we do not have the input, we do not have the output of any of this current. So to calculate the input current, we are going to consider where we have the input power and where we have the input. So we are given input power and input volt. Why are they just repeating, guys? That's the question. So you see, revising question papers is an advantage because you can see that you are given power in, power V in, power out, Z out. It's supposed to be a mix-up of type of a question, but anyway, that's what we are given, guys. Let's see. So in order for us to have current in, we talked about this, we're gonna use power is equal to voltage times current. This will be in, and this will be in, this will be in. So to end up with the current in, that will be power in over the voltage in. So power in, which is the input power, it's 400 megawatts. All right, this was actually a mistake. This was milliwatts in our, okay, an amplifier, guys, cannot carry something like that. This is milliwatts. It's actually a mistake there. So the input power is at 400 milliwatts, which is 400 times 10 to the exponent -3. The power, I mean the input power, and the voltage there at the input is 20 volts. Just imagine we've got an input of 20 volts, then we've got 400 megawatts. It's impossible. It can't happen. It will burn. It cannot exist actually. All right. So the input current is going to be equivalent to something like 0.02 amps. When you simplify properly, they're supposed to have something like in exponents, but you can just leave it like that direct. Okay, just leave it like that. But you just write the answer in a way that you want. A fraction, a decimal is one and the same thing. All right. Then let's move on to the output. In this case, as you can see, we also need the current at the output. From what we are given at the output, we are given the power, and at the output, we are given the impedance. So remember, from impedance and the power, in order to obtain current, we said power. All right, so this one is a value that you're going to need. We said power is equal to the current squared times impedance. That's I squared times Z, which is, so at the output, it's just going to be put out, and so on. So divide by Z out both sides. P out over Z out is equal to I squared. Then we just introduce the square root both sides. So meaning to say the current at the output is going to be the square root of P out. That is the output power, 200 watts. So it's going to be 200 watts over the output impedance, which is 30 ohms. All right, so there we can obtain the current at the output, which is at the output, the current is supposed to be 2,582 amps. So you can use any other suitable formula that you understand to calculate these values of current at the input and the current at the output. That one is your choice, but you're supposed to have the same answer at the end. All right, so the current gain can be given as 20, the logarithm of current at the output, which is 2,582 over the input current of 0,02. So that's it. We are going to have the input current, the input gain in this case in decibels in this case. All right, so that is going to be 42,2185 and so on, which is 219. 2185 is going to be 219 in decibel in this case. All right, so that's how our questions might be given. So let me know, guys, on the comment section which areas to work on and what to do as we are preparing for the exams which are ahead of time. I'm going to work the full paper which was written currently in August 2023 exams, so that at least you can just revise that one to prepare for the October and November exams. Mostly they just repeat one or two things from that previous question paper, especially those questions that had got difficulties to be answered. A lot of people, they were failing that question. They will bring back that type of a question. So let us just work towards that as a family of Mason African Motives till we meet again.